my name is Frances. For those of you who don't know me, I've been at Jux for just over a year, but I've only been coding for about 3.5 years, which I think gives me about as much time at the keyboard as someone sitting their GCSEs. So because of that, I'm going to hijack these talks and instead talk about some art. You can see on this agenda, we've got point 4, which will, fingers crossed, involve some live coding if everything goes to plan. So what's my motivation for doing this talk? I'm biased. Before I was coding, my undergraduate degree was in art history, and I do still make art myself. This is a picture of me. But I have also always felt that there's quite a creative element to coding, and not just in terms of building and designing lovely UXs and UIs, but also the idea of breaking an idea down into parts and building something from scratch. So when the opportunities came up to do a talk, I wanted to use it as a chance to kind of explore coding for art, so bringing together two things that I'm interested in. And one of the things I enjoyed about this is I got to kind of re-engage with how I felt when I first learned to code, that sort of newbie feeling of just trying something out and seeing what works. So importantly, I'm going to talk about my focus. First of all, I'm not going to be talking about AI-generated art. So if you were here for that talk, now is your chance to leave. I think there's a lot of interesting conversations to be had around AI art, and there's a lot of interesting comment out there. But what interests me about art is the relationships between artists and objects and viewers. And I think that the kind of massive data sets and the almost opaque black box that is AI art, it obscures the intimacy of that relationship. The other thing I'm not going to talk about is the question, what is art? It's kind of a philosophical and aesthetic discussion that's been had for hundreds, if not thousands of years. And any discussion of art could get bogged down in this and sidetracked. So I'm going to take the rule I heard on my first day at Oxford in my undergrad. One of the tutors said, we don't ask that question. If a human treats it as art, if they make it as art, or they look at it as art, then we study it as art. Incidentally, as you can probably tell, this image was generated by DALL-E 2. I think the kind of slightly melted face gives it away. So I wanted to briefly start with looking through art history for some examples of how artists have used algorithms in art before the time of the computers. And a really quick definition. So broadly, this defines an algorithm as a step-by-step procedure for solving a problem or accomplishing some end. So I wanted to think about the way that artists have used or followed a set of rules in the production of their art. The first examples that came to my head is the kind of mathematical rules of perspective used in the Renaissance, and also the really intense mathematical geometry of Islamic tiling. It may seem a bit random why I'm going back to look at art history, but I think it's a really useful way to frame how we can start to think about computer-generated art and where the role of the artist fits into that. So when Raphael was painting this fresco in the Vatican, he had to follow quite a few kind of steps and rules and procedures. So obviously the rule of linear perspective, but also the rules from the person who commissioned it. So this was done for the Catholic Church, for Pope Julius II. And then also conventions around iconographic representation. So Athena is included in this fresco, and we know it's her because she has a shield with the head of Medusa on it. So in a very simplistic way, we can think about the relationship between artists and algorithms and objects in this way. So the algorithms or the rules inform the artist, which then produce the object. As you can see, I have put object and not artwork, because for something to be an artwork, we need a fourth element. And that's the viewer, who also brings their own cultural context, biases, and opinions. In my consideration, this is where the art happens. So it's in that interplayed relationship between artists and viewers via an intermediary object. I think this is a useful framework when we're thinking about how we consider art where this immediate connection via an object isn't as clear. So getting on to the algorithmic art side of things. Again, this definition, but this time I kind of want to focus on the latter part of it. So an algorithm is designed to solve a problem or accomplish some end. And as programmers, we generally hope that the ends are defined before we start the work, or at least in the beginning stages. And we do this through research, discovery, wireframes, design, talking to clients, etc. But if we're making art, that end goal is a lot less clear, and especially when you're new to it, it can be really difficult to even predict. So even though I said I'm not going to debate what is and isn't art, I think it's useful for me to kind of lay out what I feel a useful aim would be for this. And that is, the purpose is to create something that's aesthetically interesting, that makes us think, that communicates abstract ideas, or allows us to express ourselves. And again, this definition, going back to the idea of art existing in the relationship between people and objects, this definition isn't grounded in the material world. It's not about what it's made of or even what it looks like, but it's defined within that relationship and the way it's perceived and created by humans. So how can we use code, which we in our everyday work rely on to be predictable and to have the same output every time, especially as functional programmers? How can we use that to make the space we need to experiment and explore and express ourselves in a more abstract way? How do we position ourselves in this world as both the software developer who loves the rules and the order and the predictability, and also as an artist? For a really good talk on this, which I really recommend, it's available on YouTube, Tyler Hobbs gave a talk at Clojure 2018 called Code Goes In, Art Comes Out. And he goes into these sort of philosophical ideas about how we make good code with art and why coding for art is so important for us as developers within this talk, so I'd really recommend it. So this is one of Hobbs' work. He works using Quil, which is a framework. It's a Clojure wrapper for a JavaScript language, which is called processing. And this piece in particular uses a recursive triangle subdivision algorithm. And we actually know the goal that Hobbs was working towards for this piece because he's written about it. And he says his goal was to make a work that balances human influence and computer influence. And again, this is an abstract idea. It wasn't that he had a vision in his head of what he wanted the final piece to look like, and then he was coding to replicate that. It kind of goes back again into the fact that the art itself exists in that abstract space where humans can kind of interpret and relate to each other. I think this quote tells you how he feels about how it went. And I find this particularly interesting when he talks about 2D and 3D spaces. In our lives, as technology becomes more and more embedded in the world around us, and as we spend more of our lives online, those boundaries between the 2D and the 3D become increasingly blurred in a way that I think the original computer artists of the 60s and 70s might not have even been able to imagine. Some more examples. So these two pieces, Careless and Well-Intentioned 1 and Careless and Well-Intentioned 4, are two of a set of 5 pieces which were all generated by rerunning exactly the same algorithm. And I think this is an interesting point to illustrate. Hobbes says that in order to make a piece of art interesting, it has to have an element of surprise or an element of the unexpected. So these two pieces, the algorithm was run 1,000 times, and then he selected 5 of the best to put forward into the final group. So by having this curatorial process as an artist, it means that you can write algorithms which are riskier. So you could have an algorithm which has the potential of creating some really incredible pieces at the expense of 995 absolute duds. So for him, the randomness is built into the program. That is the unpredictable element, using quite literally random numbers and random chance and random choice. And you can see how that's worked here. If it had been too far in the direction of the chaotic and the random, like looking at static on a TV screen, old TV screen, it would be really difficult to kind of engage with as a viewer. But here, there's enough recognizable structure that our monkey brains can latch onto those patterns, but with enough disruption to that structure that we still find it interesting. So as a viewer, we can see that there's a recognizable grid pattern with horizontal and vertical lines, but it's the slight deviations from that, the variations in height and the variations in the actual curvature of the lines, which make it interesting to look at. It's the same with the color palette. So Hobbes has limited the color palette within this piece, and the colors are broadly grouped, but the points of interest come where the groupings are disrupted. So you might also be interested to know that the well-intentioned 1 was sold at Sotheby's last April. And all for the crypto bros amongst us, they're also available on OpenSea as NFTs. And if you want to know how much it sold for, then you'll have to find me later and bring me a drink. The way Hobbes works is by running code, assessing the output, making changes, and then running the code again. This is similar to a painter making decisions as they work. So as you're painting, as you're making something, you're working on this physical object in front of you, and you're constantly making decisions around placing the next brushstroke, mixing the next color, you might change the composition, and it all happens live in front of you. The difference when you're working with code is that each of these images is produced in its entirety by running the program once. So especially if you're working with randomness, if you accidentally close the window that this was in and you rerun the code, it's an infinitesimally small chance you'll get the same image again. As an artist, you're one step removed from the physical production of the art. And crucially, as an artist, you're unable to completely control the appearance of the final outcome. So this is also what makes it exciting as a developer to code art. It kind of forces us to relinquish this control over what our code produces and what it looks like. It makes us loosen the reins a little bit, and I think it can help us think differently about how we approach writing. So this quote from Hobbes is really interesting. He highlights the randomness, meaning that he has to relinquish control of the final output. So as an artist, you're both curator and creator. Your work as an artist is in setting up the boundaries and the frameworks within which the computer produces art. So if we go back to our flow, we have the artist at the start. They write the algorithms, and the algorithm produces the object. Except when we think about how Hobbes works, it's kind of more like this. And again, we have the viewer perceiving that object. And I think it gets really interesting when we add those circles, considering where the art takes place. These circles are now separated because the artist does not have direct control over the appearance of the art object. There's a third space in which art happens. And here, I think, is the factor that makes algorithmic art different from being a developer who builds a beautifully designed UI. Within this circle are processes that are out of human control. Whether they're randomness, whether you're an artist who works using large data sets and you can't control the data within them, or whether it's just through the unexpected things that happen when you code without a defined destination in mind. Thinking about Hobbes's quote, talking about himself and the computer, we're partners in the discovery process. And I think that's incredibly true when you're considering coding art. It's the uncertainty within this circle that creates the unexpected, and that is what creates interesting art. The process is not a one-to-one relationship between code and output, and the decoupling of code and result gives developers the space to experiment and to bring a more expressive attitude to programming, which I realize is unfamiliar to many of us as programmers who kind of want to make something and have it turn out exactly how we want it. Okay, some adventures in Quil. So this is by Jean-Pierre Hébert, sorry to anyone who's French, who was one of the Algorists, which was a group formed in 1995 of computer artists using algorithms to create their work. And broadly, the pseudocode means that if you create something and it's an object of art and it contains your own algorithm, then you can call yourself an algorist. I'd also add that for it to be interesting, the algorithm has to have some level of autonomy, so there's that unpredictability that you need to create good art. So in just a few hours of fiddling around using Quil, which you can use locally, there's also a browser version as well, I promise you that you too can make something which you could print out and stick on the fridge. Okay, I'm gonna have a go at doing some live. I will point out that I discovered about 2 months into playing with Quil that the repo is actually dead. It's not being maintained or updated, but it is open source. So if anyone would like to fork it and update it, let me know, and I would be very happy to have a go with what you create. So here we've got a really basic program, and the nice thing about working in Clojure is that you have the REPL, so you can have immediate feedback when you make changes to your work. At the bottom, we've got the def sketch macro, and this tells the program the size, the setup, the update state, and the draw state. So this works on a system of frames per second, and I've got that set at 10. So if I run this, you can see that we get something, although potentially not very interesting. So this time when we run it, here we go. Now we can see what we're doing. So what we can do is, between each frame, the background is being replenished. So if we get rid of the background, then you can see that each of the lines is being drawn next to each other. So now when it's run, as you can see, we get quite a nice pattern, but I would argue this isn't very interesting in terms of making interesting art. So let's introduce that little bit of randomness that Tyler Hobbs suggested is needed to make something interesting. So instead of increasing the y1 variable by 10 and decreasing it by 10, we're going to add that randomness. And already, even with the little bit of differentiation, it's suddenly a much more interesting piece. We can increase that further by adding a little slightly more complicated randomness onto the x variable. And this time when it runs, you'll see along this left-hand edge, you start to get this really interesting line forming, but we can't really see it. So let's change things and move that starting point inwards so we can really see that line. So this time when it runs, we can really start to see that line. And already we've got something that's a lot more interesting than the perfectly mathematical spiral that we had at the start. So as you can see, it's very simple, it's very rewarding, it's fun to do in Clojure. Having the REPL is great, you can get that immediate feedback. And you too can make some really interesting art. So thank you very much. If there are any questions, I will be happy to ask them, but let's keep them more on the art side than the tech side. Thank you. Yeah, question at the back.
Hello, I was really intrigued by your description, your process description, but particularly because you used the word object, and you seem to be talking about it like a final artifact. Yet, like with the Quil example you gave, there was more of a process involved. And sometimes I think one of the interesting things about algorithmic art is you get to actually not just have the relationship where you have the bidirectional between the artist and the algorithm, but actually the bidirectional between the artist and the object. And it not necessarily a thing, but an ephemeral thing which has process, which is the art. Is that something that resonates, or I'm interested in your thoughts on that?
Yeah, so the question was around the idea that it's kind of more about process rather than final object. As another way of thinking about it. So thinking about things in terms of process instead of final object. I think this, yeah, definitely really resonates with me because by the very nature of the fact that as an artist, you're not working on that final object. And I'm using object in the broadest sense. It could be a sculpture, a painting, a digital image, as something as ephemeral as a IntelliJ window, which I just closed and now is lost forever. But I think the very nature of algorithmic art means that you are working on process, and it's the process that's producing the final piece. So yeah, I definitely agree. I will add that the pieces that I've shown, a lot of them have been still images, so especially Hobbs, he works primarily using still images, but it's still a process which is run, which produces that final piece. I think that for the purposes of kind of experimentation and demonstration, it's more interesting to work with the moving elements. I will add that if you're interested in this, quil.info has loads of examples, and you can view the code for all of those. If you have any questions about getting started with it, then feel free to drop me a message, and I'll be happy to help as much as I can. Yeah.
Where do you draw the line between intention and chaos? So you're programming, you're intending to do something, but you're introducing randomness, so therefore you're kind of out of control. That's sort of an interesting line for art, I think. Maybe you could think about art.
Yeah, so the question was about the line between kind of intention, and from intention on one end all the way down to chaos at the other end. And then when you're making art, like where do you draw the line, kind of how much randomness is what you want in the final piece. And I think really that depends on you as the artist and also you as the viewer. So when you're making art for yourself, you're deciding yourself how it looks. So I personally thought that the first time I ran that code was super boring. So I needed a little bit more chaos. Yeah, I hope that answers the question. It's very personal, and I think, again, that's why even thinking about the concept of art has to exist in that kind of abstract space within the people who are looking at the object, instead of it being an innate thing in the object itself. Yeah.
I wondered, as you're working at the record, have you ever found that you've created something, but then it's gone, and you're struggling to recreate it? I just wondered if you've got into any kind of workflow or techniques where you're sort of constantly trying to capture, to create some like notion of reproducibility. And do you find that, you know, sometimes like actually something that achieved the look that you wanted was then lost, and you couldn't get back to what that perfect piece?
Yeah. So the question was around whether when you're working, because things are so difficult to reproduce, if there's as part of my workflow, did I find a way of capturing previous ways that I ran the program so that I could go back to them when I made changes later on? Yeah, for me, I just took screenshots of the image and the code next to it. Which, because I was working on simple stuff, was great because it was all on one page. I think as soon as things started to get more complex, you'd probably want to maintain almost like a visual log of what each change looks like. I guess also what's really useful is using something like IntelliJ. There's a local history, so you can go back. But I think because and I imagine like once you get really into it and you get really fluent with it, you'll be able to look at the code you've written and you'll kind of imagine what it looks like on the screen. But especially as a newbie, it was very difficult for me to predict what this change would affect out the final piece. So if it was a case of me looking at something I'd made and trying to reproduce it in the code, I'd really struggle with that. So that's why I do things like take the screenshots where I can see the code I've written, and then I can kind of go back and modify things from there. But I also think that if you're working in a way where you're continuously trying to produce one very particular visual outcome, then you're kind of going about it the wrong way. The fun thing about it is to experiment and just capture what's interesting, and then you can kind of grow and go from there. Yeah, we have time for one more. Yeah.
Do you consider the algorithms, such as those designed by Hobbes, to be fundamentally different to AI models, which are, in a sense, their own very complex algorithms?
Yes, I do. So there was one artist which I did quite a lot of research on but couldn't sort of shoehorn in, called Harold Cohen, and he essentially had a very long-running algorithmic art project where he, over years, over decades, he gradually taught this algorithm more and more details about how he wanted the outcome to look. But reading through his writing on it, you realize that he's kind of training an AI model, but the only data he's using to train it with is his own experience and his own learned experience as an artist. So it's almost like a child learning to draw. They learn the figure is broadly made of like a blob at the top and a blob in the middle and two like sticks coming out the bottom. And as it becomes more sophisticated, as he writes more and more sophisticated algorithms, the computer he had, which was called Aaron, was able to draw more and more sophisticated images. And I think that AI art has just kind of sped that process up. So we've got all this data around what things look like, and the models have been trained to take a look at that data and create things and assess how close they are to that final output. And it's almost exactly the same thing for Harold Cohen, but instead of it being a model assessing how close the output was to what he intended, it was him as a person. I think I've gone on a bit of a tangent, but I do think they're fundamentally different things. And I think that if you're training an AI algorithm, you're even another step removed from the production of the final object. And I think that I mean, I've never trained an AI algorithm, but I imagine it's a very different process to having that immediate feedback between what you're coding, what you're writing, having a direct impact on what is being produced. Okay, I think I'm out of time, but thank you very much.